you.
Thank you. Thank you all. Can you hear me okay? Yes? Okay, I'm really excited to be here. Thank you so much for coming. The first two presentations, I think, created really great foundation for us to start the conversation of measuring creativity across different contexts, in different type of modalities, and definitely the future of AI is so essential for us in terms of conversation. I think it brings a lot of questions such as, are we going to rethink the way we measure skills? Are we going to rethink the way we help kids develop those skills? How about the digital space versus the physical space, right? We were touching on mostly the digital space, how learning is happening, how interaction is happening in digital space, how we measure skills in digital environment, but what about the physical part of that and how those intertwine? So I will try to touch on those dimensions, but really the two main strengths of this presentation are going to be more of a reflection on the work we did so far with PISA 2022 Creative Thinking, the first global assessment of creative thinking. So I will share a bit more insights on that without stealing the thunder from the actual report that will be released towards the end of this year or maybe even early next year. So it will be more of an insider view, reflections on what we did, and definitely I'm hoping a good foundation for discussion for the Q&A session with the audience later on. So this is going to be the first part. The second part is going to be really focusing on the way we were building on insights from PISA 2022 and the work done in other organizations, in other contexts, and really helping develop certain formative assessments that can be part of learning experiences. This work is done with Lego Foundation and, of course, through collaboration with BrainPop. So I would suggest we start with the question why. Why are we trying to even measure? Why are we attempting to measure creative thinking or creativity? Why this is so important? Is this even valuable, feasible in the age of AI? Why this is really something that we need to, to think about. And just to give you the context of, first of all, this decision by the OECD governing board to pave the way into that space. So 5-6 years ago, when the representatives of different countries, part of the OECD partners, decided to add this additional, what we call innovative domain into PISA 2022, and really on top of the key domains such as mathematical literacy, scientific literacy, and reading literacy. Those are the core domains in PISA. And as you may know, PISA in part is also a vehicle for us to be able to test new capabilities and really add skills to the framework. So it's no longer about those core domains, but every new cycle there is a new domain being added. The previous domains, for instance, included the ability for kids to collaborate and solve problems. So collaborative problem solving was the main domain in 2015, and so on and so forth. So there is this attempt to really build the framework for PISA, for the countries to be able to really see to what extent 15-year-old students are able to really demonstrate their thinking, in this case, creativity. In other cases, it's really those other skills. As you may know, future-looking innovative skills are going to include, for instance, the ability to learn in the digital world, to be able to even potentially interact with AI tools and really empower you as a human to be able to, for instance, demonstrate how you can generate certain artifacts or come through certain experiences that involve AI, involve those capabilities. So the creative thinking was defined as the innovative domain for 2021, then it moved into 2022 because of the pandemic situation. But we were lucky to really extend the timeline to build and validate those tools, because this definitely was the first time that this creative thinking skills were introduced as a domain that we can measure in such a scale across so many countries, so many cultures and languages, which is, of course, a very important constraint and also opportunity for us. So when we ask this question, why we measure those skills, I think the more even important questions we should ask ourselves is why and how we can help kids develop those skills in schools or even in activities and experience kids or children or adults have outside of schools as well. And definitely we are looking in a broader sense, right? So it's not necessarily just about coming up with diverse ideas, which is really the focus of most of the previous attempts to develop those type of assessment capabilities, really kind of narrowing down creative skills or creative thinking skills into what we might call divergent thinking. So most of the previous attempts are really focusing on divergent thinking. And if we think about AI capabilities, with definitely the highlights we've heard from Katrina and the publicly known capabilities of generative AI, we might say that maybe divergent thinking, they're able to come up with just infinite number of diverse, different ideas to a story or even solving a problem. Maybe this is not the major skill within this framework I think we might need to focus on. So we are looking into much broader skill set, such as the ability to come up with original ideas, how originality is connected to innovations in society and technology, to what extent this is going to be a skill that we can actually embed into the more of a traditional domains, such as science, mathematics, and language arts and social studies, right? So this is much, much broader than really this previous focus of most of those assessments, most of those capabilities into divergent thinking. We know that there is a very high positive correlation between creative thinking and the ability to also succeed in whether it's a STEM career or in other domains. So we do know that there is high correlation. We do know that it is essential to develop those skills, but now it's more really about where we might want to emphasize, where we might want to create much more weight, whether it's, for instance, divergent thinking or diverse ideas or some of the other domains that I'm going to talk about in this presentation. So when we established this expert group, with really the most prominent researchers in the creative research and creative thinking, we really we're trying to come up with a competency model that will really bring those streams of thought and work into the ability to measure those skills, right? So you might say, this framework, this competency model, that includes generate diverse ideas, generate creative ideas, and evaluate and improve ideas is insufficient, right? So there's so much, for instance, and I think this is what we heard from Rebecca even in the previous presentation, there is so much of the actual process to be able to effectively engage in creative thinking, right? Even before you arrive to coming up with new ideas or original ideas. There is so much to certain questions you might want to ask. There is so much to even questioning the problem that you're trying to solve. So what we're really focusing on is really the ability to operationalize this competency model. So what are those skills that are both valuable, we have strong research evidence on, and also we can measure within the constraints of this global assessment. Right? There is so much you might want to do, and really you need to kind of focus on things that you have strong evidence that you can actually measure across, again, different languages, cultures, and within the framework of 15-year-old students. So the definition we, as an expert group, came up with was that we define creative thinking as a competence to engage productively in the generation, evaluation, improvement of ideas that can result in original and effective solutions and can boost advances in knowledge and impactful expression of imagination. Now, if we will apply similar exercise we've seen before in terms of where AI, generative AI, can potentially almost compete with this definition, you will see that there are domains such as the ability to advance knowledge, for instance, right? This is something that is much farther looking than the ability to replicate through, major data sets. The expression of imagination, right? The ability to evaluate and improve in a way that not many other peers, 15-year-old peers, but now we can add maybe GPT model trained to act as 15-year-old kid, right? So this is the thinking that we had before. This was not informed by the advances with ChatGPT. It was more about really where we see value and where we have strong research base and where we can actually, measure what skills can be measured. So these are the three competencies, three skills that we were optimizing the assessment for, and there is a long process to validate the operational definition of each of those skills, what are the different levels, to what extent we can train teams across all of these participating countries to be able to evaluate all these responses, all these artifacts that the kids generated is part of that assessment. I can tell you this is the first assessment, the first PISA assessment that had no even single multiple choice question. So everything is performance-based, right? So there is no multiple choice question to evaluate, ideas that somebody else created, or come up with more of a type of like memorization type of outcomes. It was really very much process focused. So the ability to engage in the process of creative thinking and very much focusing on those our ability to be able to evaluate those artifacts and really make inferences on the level of skill or proficiency on those different skills. So this is definitely was a very significant undertaking. Just it's definitely much easier to have an assessment that will have a significant percent of those item types that you can easily use machine to score. So there was a significant undertaking not only to be able to validate that those items, those questions, those challenges that we provide to students to be able to demonstrate the creative thinking potential will work across different cultures, languages, and will produce evidence that we would like to see to make those inferences, but also the ability to now use the scoring rubric and train teams across all of those countries and be able to show that there is a significant inter-rater reliability that is compatible with other PISA domains such as science or math or literacy. And I'm happy to share that we were able to really fine-tune the scoring rubrics, definitely the assessment tasks, but most importantly, the scoring rubrics to the level that we achieved almost a similar level of inter-rater reliability when humans score those responses as we see in open-ended responses in science, for instance, when kids are supposed to demonstrate their scientific reasoning and explain their answer on questions in science. They're expected to also produce the performance-based response, constructive response, and then we see that we reach that because this was the expectation, that this assessment will have to be really objective. We'll have to have this power to see that it works well across different languages, different cultures, but also we can train teams to be able to to evaluate that. Whether or not we can train a machine to evaluate that, yes, we are working on that, but this is not part of the PISA workflow. It's much more of a workflow that I will talk about with the LEGO Foundation and BrainPop, the work we are doing really to save time by grading those type of responses, those type of artifacts based on larger data sets that are part of that process. So in terms of now ways of expressing creative thinking, ways of or a context where students can apply their creative thinking, we were looking across the board really to make sure that this assessment will not gravitate to the obvious domains, right? So typically you will say, yes, I will focus on the domains that are much more conventional, will be less subject for certain biases or certain challenges that will be introduced to the scoring teams, right? So we really wanted to make sure we cover the expressive domains and the problem-solving domains. So you see here we have the written expression and visual expression domains, and means in each domain we have sufficient number of tasks or challenges that students will work with and demonstrate their ability to apply creative thinking in written expression tasks, visual expression tasks, and the scoring rubrics were optimized for that domain first. And then we were looking really to engage what we call the problem-solving domains, right? So problem-solving domains, really, it was a broad definition. What are those authentic type of situations or contexts where we would expect 15-year-old students to be able to apply the creative thinking, and we basically created the range of those domains, more starting from social problem solving and going into more of a mathematical or scientific problem solving, much more of a scientific or even, I would say, engineering problem solving. And the main consideration here was that we do not want to really engage in the prior knowledge, because if you think about this global assessment, it is very possible that there is more emphasis on, for instance, engineering type of task in one region or geography versus the other geography. So we do not want to be in that situation. So we basically optimize those tasks in social domain problem solving and in scientific problem solving to type of challenges to tasks that will not really involve that prior knowledge, or at least not, we will not see like strong evidence that this is what making the difference for students. So we're testing that across different countries, again, different cultures, languages, to make sure that there will be nothing that will underestimate the ability for students, 15-year-old students around the world, to demonstrate that creative thinking application across those 4 domains. In the assessment framework draft that is publicly available on the OECD website, you can see some examples of those tasks, but those are really just the type of tasks that we really administer. The actual tasks are confidential at this point. I'm hoping that very soon, with the publication of the actual report, we will be able to share some sample tasks for each of those domains. So you will see that. But just in generally speaking, how the visual expression task might look like, you're basically using a drawing tool to, for instance, communicate certain idea with your peers, right? And there is a prompt, there is a stimulus, and there are tools that we tested that work well, so they will not require any, training for kids to be able to engage. It's a very simple way to really communicate your idea with others, and there is a very specific also basically expectation that we communicate to students, because we've seen in the cognitive labs, and I will talk about this later on as well, we've seen that it's very essential for students to know what is the success criteria, right? Because it can be very hard when in science and math you know exactly what you would expect in that domain, what would be considered as full credit, right? So we were not being explicit in each task what exactly this need to look like, but we were really creating that what we are calling orientation unit for all the students when they started creative thinking to really empower the students to think creatively. There is no expectation for certain correct versus incorrect answers. So there was a lot of guidance for kids just to start the process, because you can imagine if you engage in a scientific unit in PISA and then you go into creative thinking, suddenly it's a different ground to play in. So we were basically prepping the students to make sure, yes, it is encouraged to think in a different way. There is no correct answer in this, in this challenge, right? You really have to think differently. And the prompt that we found working real well for kids was in this especially task that were focusing on coming up with original ideas, unconventional ideas. We were very explicit with students. We were saying, think of an idea or a solution to that challenge that you introduced that not many students of your age will think about. Right, so what is this group you compare to? This is the group of your peers, essentially, right? So it's not necessarily that nobody else in the world never thought about this idea. It's really about your peers, right? That was the context. So just to give you some flavor of the scoring rubrics, and you may, ask if this is something that can be done, can be machine graded, but we were really optimizing that for human grading and really making sure we will reach an acceptable internet reliability across all the teams, across all the different countries. So we're training, basically, the teams to follow these guides. And in general, we were looking into simplified version of the rubrics that can be applied very efficiently across the teams to, at most 3 steps. So the first step was really focusing on the appropriateness of the response. You might claim that in creative thinking space, appropriateness is questionable. Like you might actually want to see some response that will not follow that template, and they essentially can be, defined as inappropriate, but we defined it in a very broad sense. So responses that respect the task, form, and connect with the stimulus, with the challenge the student was supposed to work on. We were very careful, and we were actually invited students, when they submitted their responses, to explain the answer, because it is very possible that when you see the visual artifact, think about the visual domain, when you see the visual artifact, at first glance, as an adult, you might not understand. You might, say that this is actually, I don't see the connection with the task, right? So we ask students also to basically provide like somewhat of a comment, just to help understand what is the intention of that. But otherwise, it was very low bar. So there was no intention anyway to disqualify responses. It was more about whether it's on task, very general. If not, so essentially it will be no credit right away. But most responses will flow into the next step. And then if this is the skill of generate diverse ideas, broadly speaking, we were looking into the qualitative difference between those different ideas that students will come up with. So not necessarily just, okay, this is pretty much variation of the same thing, right? It was really, what are those themes that we've seen as different ideas, qualitatively different ideas, and to what extent these 3 or 4 ideas that students came up with, that a student came up with, or a test taker came up with, will fall into those different themes, into those different topics we identify as qualitatively different approaches to solve the problem, or qualitatively different solution, or qualitatively different idea. And this was the distinction between partial credit and full credit, right? So this was the process here. And then the most challenging, I should say, part of that process was building those rubrics that will work effectively and will show strong psychometric property here, was really this focusing on generate creative ideas. So this is really about originality. I think Rebecca referred to that a little bit in her presentation. But so this was a bit more enhanced process, where it starts with appropriateness criteria. It needs to be on task, and we were very low bar. There is no expectation to disqualify any highly creative ideas that we just don't connect to the challenge. But the next part was really the benchmark of, is the response has an original theme or an original approach. So now, how we derive to that? This is something that requires some training, right? So you can't do that without proper data sets. So that's why we were going through this long process of running cognitive labs with students, interviews essentially with students across many countries, participating countries, verifying what are those conventional, common approaches, common ideas that students will have for certain problems. And then typically we define 5 to 7 of those more conventional approaches to each of those challenges included in the PISA assessment. And then anything that falls beyond basically this 5 or 7 themes that we found as common will be defined as unconventional. Right? So, and it's not to the human adult reader to define whether it's original. It's really if it's going to be outside of those 5, 7, 8 more common ideas and themes that we found on international scale. Right? So, of course, as we have more data, we can optimize that. You can say, oh, actually, there are a few more that are pretty common. We thought that they're uncommon, but they are essentially common. So definitely you can optimize that over time. Within the time frame of PISA, we really validated that through not just cognitive labs with students, but also validation studies that we ran in 2020 and 2021 to really inform those themes. So basically, we we enhanced the scoring rubrics between the field trial, 2021 and 2022, into the 2020 and 2021, and then basically those enhanced rubrics were used for the main study in 2022. So this past year. So this was the process. Definitely, there is, in the future, when we ask about the AI capabilities here, I do think there is a lot to do here to be able to, first of all, identify those, common themes and be able to really train kind of auto-grading capability to, to help with that process. So then basically it's a grading co-pilot if you think about this, right? So it doesn't mean that it needs to replace the human in that sense. It's more about this is what AI grading came up with, and now you basically can overwrite as a human rater. You can review those responses, especially if this auto grading capability will also include the the confidence level. So in certain responses, certain type of responses or tasks, you might not reach the confidence level that will be acceptable, especially for summative assessment. Formative assessment might have a different criteria. And then basically you say, these are the 10% of the responses we do need human to look at, right? So you can do that. In PISA, we haven't applied that. This was really more of a forward-looking capability. So this was the process, right, to build this major global assessment, starting with face validity, really, the expert group engaged in that, running those cognitive labs or interviews with students and really leading through all of those different stages of validation towards the actual 2022 main study in PISA. I do want to use this opportunity in the 5 minutes I still have remaining to touch a little bit on the formative assessment, how we can actually engage students in more of a learning through play experience, and how we can actually measure those skills, what you might call in flight, right, while students actually engage with those skills. And this is where we're introducing basically additional sub-skills. So you might recognize that those three, generative original ideas, diverse ideas, and about to improve are actually based on evidence from PISA. We know we can measure those skills. We can definitely create much wider range of opportunities for kids to demonstrate those skills. But we added two more, and these are really essential in my view. So the ability to effectively engage in creative process, just to ask the questions, to question even the actual task the students receive. There is a lot to do in that, and there is a lot to do also with the level of facilitation that might happen if you are not in the more of a PISA type of assessment setup, right? So if you think about the classroom, about the role of the teacher in that sense, or role of the parent, if this is something that is happening outside of the classroom, the ability to engage in creative process, but so this is almost the entry point. Then you're going through those PISA creative thinking scales that we know we can enhance even more in the formative assessment space, but then going to the more of a highest level of creative thinking scale that we haven't applied in PISA, again, just because of the constraints. In this new work that we have established now with the LEGO Foundation and BrainPop, we are looking into the ability to basically transform the idea, the ability to really come up with a new paradigm, right? Something that, and reflect on that. So this part is not something that we've built for, we've optimized in the PISA assessment. Definitely this is something I think will become even more and more important with the new generative AI capabilities. The human ability to reflect on those new ideas, the ability to really not just come up with original ideas, but with ideas that will be truly transformative, right? And be able to communicate those ideas with other humans. So this is part of this more extended framework, if you will, for creativity. Okay, so I will skip a few slides just to kind of focus on some of the other capabilities. I know in the previous presentation we were focusing so much on generative AI, but I do want to touch at least a little bit on the other capabilities where AI and ML can be super helpful. So first of all, in this new line of work, we are looking to engage kids not only in the digital space, but also in the physical space, right? So kids can actually build stories or build certain artifacts outside of the digital system, right? And then engage in this creative thinking activities, and then basically upload those artifacts to the digital system where we can help kids to demonstrate knowledge, make inferences, and really create more of a personalized pathway for them to further develop those skills. So this was the process, and really expanding beyond just 15-year-old students like in PISA. We have kids from 6 to 12-year-olds engaging in this learning through play processes now with the LEGO Foundation and BrainPop, and the task can vary. It doesn't need to be just those 4 domains that we have tested in the global PISA assessment. We can go far beyond that. We can engage kids in, for instance, teamwork, or for creative thinking teamwork when you actually interact with another human and build a model, and you need to explain that, and you need to optimize, right? So this physical, digital space transition, engaging other humans in that process is very essential for definitely whole child development, and this is what we are looking to engage kids on and build those new capabilities. And these are just some examples. It doesn't need to happen even in their homes. It can even happen in their backyard, right? So they can develop certain artifacts and transform those ideas. So I know we are towards the end here. I just wanted to mention some of the other capabilities beyond just generative AI that I know we are touched on so much in these sessions here. So we are looking also to really engage some of the AI, ML capabilities in our enhanced ability to make inferences about progress students are making in their skill development, in their understanding, in their knowledge. And this is where those new models can be super helpful because we are training those models based on really large data sets. So as we have more and more students, kids involved in those different projects that involve physical space and digital space, different types of context and different creative thinking skills, we are building models that improve over time. So you can see here an example of this new model that we applied in that project of creative thinking with the Lego Foundation and BrainPop, and we are able not only to make inferences based on pure assessment items or questions or challenges, but also on any type of activity students are engaged in, whether they are watching BrainPop movies, part of the experience, or they engage in reading some reading passages, or maybe even working with the ChatGPT just to help empower their own work. So we basically are using those, what we call engagement events, to make inferences. And when we're feeding those events, this data, into the model, we have much more accurate prediction of where they are, what will be their performance on the next creative challenge, essentially. So it is predictive modeling based on inferences we can make from what this specific student or child experienced so far, but also based on what we've seen from thousands of kids of the same age group. It doesn't need to be the same age, but age group. And then we can train that and we can make inferences. So you can see in that, again, I will skip some of that here, but just to show you some examples of visualizations, we basically are able to see how students build those skills as a function of different engagement events, different projects they're engaged in to build creative skills, or different learning activities that they're engaged in. And so we can see, and those transitions are basically students that start at a lower level of one of those creative skills and going to the higher level. In some cases, it's actually quite the opposite. We initially assume that the student is on a higher level. As we have more and more events on creative thinking, we actually build more accurate estimation. Students, there is more to work and advance on those skills, right? So these are the type of capabilities that really helping in real time to trace where students are and really build more personalized pathways for kids to advance in creative thinking or any other skills. So these are, you see, this is now by sub-skills, same students, and how they make progress and basically how they're moving across different proficiencies, again, based on the current data. From what I've seen so far, definitely there is so much power to those type of assessments. We've seen very strong evidence from PISA that we can actually measure creative thinking, which is a big question. If it's can be measured, based on our definition, it can be measured. It doesn't mean that we can measure all of those different dimensions, but the more important part is how we help kids build those skills and to what extent we can build learning progressions that can drive this learning, and really assessment that is more of playing the formative role, really helping us to see where students are and really shape their experience in such a way that it will be optimized to build those skills. I do think there is a lot to this more of a multimodal setup in that space. So I know so far we were really focusing on more of the digital space, right? What can be done, how generative AI can help in that sense. But there is so much to that combination as humans to really our interactions happening in the physical space with other humans. So there is still so much work so many challenges. I'm looking forward to engage with you and with other colleagues on how we can basically bring that framework of creative thinking and AI, ML capabilities across the board, whether it's in the classroom, or for formal learning, informal learning, learning that is happening through play, just outside any of those formal systems, and how we can basically help kids shape this more of a forward-looking, holistic skills capability, as opposed to just focusing on a slice, like a small slice of that of that more of a future-looking, future-proof capability in that sense. Yeah. So I just wanted to acknowledge again, some of this work is really, or most of this work is done in collaboration with so many colleagues at the OECD, ACT, Lego Foundation, and at BrainPop. I'm hoping we can share those slides, but there is a list of references, or selected list of references that you might want to look at. Definitely, soon we will have the full report from PISA 2022 Creative Thinking Assessment. There will be much more, also some of those sample items that I can't share yet at this point, but I think this is also going to be very exciting for you to look at. Yeah. Thank you so much.